Todd-U.
Good morning, welcome to Todd-U. Today we're going to be working on some electrical symbols, some JIC symbols. One of the reasons we have electrical symbols instead of just drawing out what the actual parts are, it makes it universal across the world. In other words, somebody in France could be looking at a print that somebody in Germany made and they understand the print. And it really makes it pretty simple after you get the hang of how these symbols work. They kind of look like Chinese right now. So what I'm hoping to do today, we're going to draw a simple circuit, talk about how to draw them and how they move on schematic. First thing we're going to start off with is a battery. So a battery is shown like this. The larger terminal up here, or the larger T, is our positive, and the smaller one is our negative. This is a symbol for ground. This is a starter motor. Starter motor with solenoid. Where most of our circuits end up starting is at the starter. We have a big heavy cable that comes from our battery, goes to our starter motor. Our starter motor has to be grounded or it will not work. We go from our starter motor and we use that for a connection point, and then we're going to go to a fuse box. Firing up that whole side there. Put a fuse in. Come through. Go to our key switch. Key switch has, your typical key switch is probably going to have 4 different positions. This would be off. This would be accessory. This would be on. And then we have start. Now, a lot of your circuits will use something called a relay. A relay is a really handy device that's been invented. The purpose of a relay is to hold a large amount of load using a small amount of current. So we're going to draw one here today in this schematic. We will be doing a video specifically on solenoids and relays later. So this kind of intro for that. A relay is based up of a coil of wire and an electromagnetic switch is what it amounts to. One side of my relay has got to be grounded. We put this up here for our starting circuit right here. When I turn my key down into the start position, it's going to go up here. It's going to provide power to my coil wire. A coil wire with an iron core in it that is grounded is going to become an electromagnet. It's going to draw this switch over magnetically. This is going to go to my load, which would be my solenoid up here. It would be my S terminal. Little tiny terminal of my S terminal on my starter. For all this to work though, I have to have another constant source of power. So I'll take that constant source of power off my starter right here, just using this for a connecting point. This is something that needs to be remembered. When you are taking a line and crossing over another line that you're using, you need to put some kind of hump in there so you can show that that is not a connection point, that is actually just one line crossing another. So here we go. Start the battery, go to the positive source on the positive terminal on the starter motor. I pick up power there and go down to a fuse terminal, or it could be a circuit breaker, providing power to my key switch. My key switch goes down into the start position, makes my electromagnetic field in my relay, sucks my trigger wire over here, provides 12 volts to my solenoid and my starter motor. Motor turns. All right, here's some tips on these electrical symbols. If you think about what we operate with electricity, we operate lights, we operate motors, we run heating elements like glow plugs or intake heaters, or we provide power to solenoids or relays. So if you think about it like that when you're talking about an electrical circuit, you can kind of narrow down and dumb it down a little bit to make it so you understand it. So starting off with a very simple symbol, this is a one element light bulb, meaning that it only has one function. This would be a two element light bulb. If you got a vehicle that's only got, one headlight on each side, and you got high beam and low beams, means that you've got a two element bulb. One would be for high, one would be for low. So beyond that, we go into motors. This is a typical DC motor. This would be for like your fan circuit. It also could be for your windshield wipers. This would be a motor with solenoid. This would be like your starter. This would be a similar for a relay. What we're actually representing here, when they actually draw this symbol in the JIC symbol, they don't show that coil of wire in there. That's one of the things that I do, so you understand that there's a coil of wire in here that when you put power and ground to it, makes an electromagnet and draws this switch over. This would be the control point. This would be a hookup, 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 and actually there's actually even a hookup here. So it's got 5 prongs on this Bosch relay. We will go in deeper into that later. This would be a simple coil of wire. Coil of wire, where we need a coil, every time we have a coil of wire, we're going to have resistance. Or we could put an iron core in the middle of it, and then we would be making another electromagnet again. Something for like your AC clutch, for lockup pressure on it. A heating element would be another one. Now, these are all components, so these are all individual components here. When we start using them in schematic drawing, we're going to have to put power to them, and we're going to have ground. You got to remember that your ground is absolutely just as important as your power. So this element here would have a positive source coming to it, and it's also going to have to be grounded. This is going to be something you find like in your intake heater, has to be grounded. Here I'd have a positive source coming in, it has to be grounded. This is going to be for like your electromagnetic clutch. My relay, one end of this is going to have to be grounded, the other one's going to have a positive source to it to make my electromagnet. So we can control this switch to make something go on and off. Your starter motors have to be grounded or they won't work. Your other regular DC motors have to be grounded. My lights have to be grounded or they won't work. So this is what we do with electricity. If you think about it, what do we operate? We operate motors, we operate lights, we operate heaters, we also operate speakers and things like that, or a horn. There's some other things that we operate, but this is what we usually are looking for when we're trying to find, going through a circuit. We have a beginning and an end. Hope this helps.
Thanks for watching. I hope you've enjoyed today's video, and I hope you've learned something new. If you would like to learn more about what it takes to be a technician, or just how something works in general, please feel free to check out some of my other videos. I'm Todd with Todd-U, and I will see you later.